Oh, hello, I am Doug. I am the iOS staff engineer here at Volt, as was mentioned. I was also the second person to commit to the iOS repo here back in the day. So I've been here for a very long time. I've gone through a lot of all the things that Nick mentioned earlier. So this talk, though, is about one of our big migrations that we did, probably the biggest, which is that we migrated our code base to Swift 6. And the title might give away a bit of the fact that it wasn't necessarily the easiest or most straightforward thing ever to do. So I figured this might be interesting for people to hear about. So basically, let's start with just a quick summary of where we are. So we're Volt. We have an app that's now about 10 years old, give or take. Maybe it's even a little bit more according to what Nick managed to dig out from the repos, but about that old. And basically this has gone from, as you see, like one person writing MVC in Objective-C. That was one of our founders who did that. And nowadays we have like 40 people writing stuff with much more architecture in Swift. And so obviously there is lots of history in this app because like we've never really done a full rewrite of the app. It is like one continuous code base from those early days, but we have like no Objective-C code left in the app at this point. But like there's a lot of history here. It's not a simple setup, let's say. So the situation now then is that we want Swift 6. But because it's new, it's nice. And well, the thing is, I've been worrying about this for a while now. When we started this, but this is like we're now talking about a year or a little more ago. So basically, I was worrying about this because like huge code base, lots of history, weird things going on. Swift 6 is quite a big change. So basically, like most of the changes we need to do would probably be fine. That's just work, but there is strict concurrency in Swift 6, and that is the big new thing. And it's not going to be easy for many reasons, but we really want it because we have a big problem generally, which is reactive programming. We obviously we use a lot of reactive stuff in the app, in view models, in services. Like it's an MVVM app, so this is quite normal. It is very reactive. And the thing is that mixing this reactive code and UI kit can be a challenge in the best of cases. And basically, the main thing is UI kit wants everything to happen on the main thread, right? We are all familiar with this. And the reactive code can run anywhere. And the thing is, like, the reactive code can switch threads, but that introduces a delay into the chain. You might miss a run loop. This leads to like visual glitching when you have animations that rely on which exact run loop you are in, and you can get race conditions that can even cause crashes with table views. And like generally, it can be a challenge to get the reactive stuff running properly. So we want to make sure that reactive updates always happen on the main thread, but there's no way to really enforce this normally in the old world, let's say. And so what we did, we had conventions like you're meant to implement your reactive code this specific way so that it works nicely. And like that works fine when you have like 5 people working on a code base, but when you have 40 people, it's a very different situation. Like you're not going to be able to remind everybody to do everything the right way every time without any guide rails, so to speak. So like conventions aren't enough. Now, the nice thing is that if we have strict concurrency, it gives us those guide rails. It enforces that we write our threading code correctly. The compiler helps us out here. It's really good. We want it. But then the problem here now is we built a lot of this on Reactive Swift as our reactive framework. And like when we started this, it was a really nice system, but like looking into this, I'd noticed like there's not a lot of development happening on this. Like are they ever going to have any support for the Swift 6 strict concurrency stuff? Because they very much didn't. So it wasn't looking good. But like we have reactive Swift code like in the entire code base, and we can't easily just replace it with something else. Like it is in every view model, in every service. We have a lot of view models. Like we're not gonna sit down and rewrite all of this code with a different system. And as I said, reactive Swift doesn't really support strict concurrency, so we're blocked. We can't migrate to Swift 6. That's the end of the presentation. Thank you. Well, not quite. Instead, we need some kind of plan to deal with this. There's a slight spoiler there. It's a slightly mad plan. So to start this off, I started thinking here, like, how much of the reactive Swift stuff are we actually using? Like, we're using it a lot, but how much of the actual functionality that it provides are we using? And could we just re-implement that functionality ourselves and try to do it the right way around? So it turns out we were mainly using property. There's not really an equivalent of this in any other reactive system I know of, and signal producer, which is like a cold signal in Rx or stuff like that. And we have already been starting to replace the signal producer stuff with async await because we were using it for things like networking and stuff where async await is a much better match anyway. And the other stuff that was where we use signal producer, we could use combine instead because it's very similar anyway. Now, the property that's slightly different but the way it's implemented in reactive Swift is that they have this lifting operator where they can like take the functions that are implemented on like signals and convert them into properties automatically so that you sort of get the functionality for free. And so then we figured that, well, could we just do the same thing, but we lift the stuff from combine, like we use combine publisher and use this lifting approach to create a new type, which works like this property that we were using. So that was the vague idea of a plan here now. So what are the actual steps of doing this? Well, we need to re-implement property on top of combine using pretty much the same API, not necessarily exactly the same API, but very close so that there's no big changes. And then we can make some helper code and things to convert the signal producer stuff. We have to use combine instead. And we can, make little changes here and there to sort of fix whatever, like these APIs aren't going to match perfectly, but we can just fix those by hand, basically. And once we have all of this done, then we can start migrating to Swift 6. So these steps didn't necessarily happen in this order when we actually did them, but that is the outline of the plan for how to get towards Swift 6. So first we try to re-implement property. So we studied like the original code for it and tried to understand that, how it works. And this wasn't necessarily easy because it wasn't easy to follow, and we had to create more and more complicated test cases to try all the weird edge cases and making sure that we matched the behavior exactly. So we didn't end up with any problems during this migration. And the one big thing was that there's a different ownership model between reactive Swift and combine. Like you use combine, probably when you listen to something, you have to store the cancelable object to keep it alive. It works differently in reactive Swift. You don't have to store anything. The ownership goes the other way around, and that's kind of a problem for getting this ported directly. So what we did was that we used some associated object hackery to implement basically the reactive Swift ownership model in combine and in other stuff so that we could optionally use that instead, at least while we were migrating things. And another thing we did here was that we could use some some types as tags on the property to mark which things are running on any thread and which ones are on the main actor to help us out. Now here's a little code snippet. This is just to show how the property stuff looks in general. Like, this is just a very simple example. We set up a property which has the value 1. We create another property by mapping the first one, and we just map it by multiplying it by 2. And then you see we can read the value of both of them. Like, that's the nice thing about this property. Like, you always have access to the value even after mapping and combining and filtering and whatever. So that is the thing we wanted, and we managed to implement this. Then we needed to convert the signal producers. Like, we got the property sort of working. So now we needed to make it possible to change the signal producer stuff we had to publishers. And it's a little bit late to mention this now, but Combine doesn't actually support strict concurrency either. So that's a slight issue. Basically, if you looked at it, you may have noticed that it doesn't really support the idea of main actor things at all. It doesn't generally even use sendable closures. It's a very old-fashioned API at this point already that doesn't really match the Swift 6 model. So to work around it, we still thought we wanted to go with Combine because that is still the official one. So what we did was we implemented this new library, which we called Main Actor Publisher. And the idea here is that we created a new protocol that is like a sub-protocol of publisher, but it's sort of a promise that this publisher will always publish its values on the main actor. The idea here being then that when we have this promise, then we can use things like forcing it to use the main actor in cases where we don't know. So like, and then we can, like, Combine has this really elaborate type system where all the, like when you map and combine and things, you get these really complicated types that contain information about your upstream objects. So we could actually use that to propagate the information that this is only happening on the main actor to like downstream things. So like if you have a publisher that only publishes on the main actor and you do a map on that, then you know that the result will always publish on the main actor because map isn't going to move it to a different thread. So this is a way to actually quantify this and prove it to the compiler. So here are a couple of snippets. I can show you how this works. So basically this is just the implementation of this protocol. As you can see, it doesn't add anything. It's just the exact same protocol. It just is a new type. And this is the promise that this will always publish on the main actor. Then we can implement something like this, like a function sync on main actor, which takes the closure it receives is marked main actor. So we know this will always run on the main actor, and then we can use this main actor.assume isolated, which is a function that says that like we know this is running on the main actor. Just tell the compiler that yes, it is, and it will crash if you're wrong. But we have a promise now that it's never going to be wrong because we're using main actor publisher. And then we have all of these extensions where we do stuff like, for map, if the upstream is a main actor publisher, the result is also a main actor publisher. So this way we propagate this information through the type system. 1 second. So that lets us now use Combine for the cases where we don't use this property thing. A little side step here is that we were also using these binding things from Reactive Swift, where you can bind properties to UIKit things directly, and we've used quite a lot of these in the app, so we kind of need that as well. And this requires the Reactive Swift ownership model because, like, when you bind it to, like, when you bind a title to a button, then we don't save a cancelable anywhere. So we have to use this other ownership model. But luckily, we have implemented it. So, and we can also now reuse a lot of the code from Reactive Swift, their binding stuff, and just we add a little bit of extra code to make it more agnostic to which reactive system we use. So that means we can use it with both our new property thing and with the main actor publisher, or with something else in the future. This is maybe slightly less interesting, but there is some code examples of what it looks like. Like the bindings at the bottom are very straightforward, and this is how they're implemented. They're like pretty simple things. Like this first snippet is basically copied from Reactive Swift, just slightly tweaked. So now we built a lot of things. We haven't done any migration yet. So what do we do now? So basically, we have some of the parts we need, but we don't really know if we have enough parts. Like, we've only implemented this, we haven't actually used them yet. And we know that the APIs we implemented, they don't match 100% because like it would be awkward to do that. Like, there are some small differences that we wanted to make, which would just make it easier in general going forward. So yeah, we don't know what we're missing. We don't know how many of these small changes we need to make. We just have the parts ready. So it's time to find out. So let's see. Basically, yeah, we couldn't really convert all of this by hand. Like, we tried a little bit to do an experiment with, like, we take a small part of the code, we convert it over to these new reactive things, but then you have to have interoperation between the different reactive things because some downstream dependency is using it, and we have to be able to convert back and forth. And it turned out like that just multiplies the work massively. Like, it would take us years to get through this by doing it bit by bit. So that is not really an option. Instead, we need to change everything at once, but that's a lot of work as well, and you couldn't review that PR. That PR would be insane. So that is a problem. So like, yeah, it will take too long, and also while we're doing this, the actual code base will be changing, so we will be constantly having conflicts. So like, we're blocked again. Like, we can't do this migration now. So yeah, that's the end of the talk. This joke might be getting old now. Okay, like, we still don't know what to do. So we figured it's time for a big leap of faith here. So the thing is, a lot of the changes are basically search and replace in the code base. A lot of these things we can do with search and replace, or like slightly more advanced search and replace. So what if we didn't actually do the changes, but we wrote a script that does the changes? And as a side note, Perl is really good at search and replace with regexps. You know, just putting that out there. So a script, we could create a script. So what do? We take the latest main branch, we run the script on it, we try to build this and test it and find out what still needs fixing, like what doesn't build after we run this script. And then we change the script and we start over. We take the main branch, we run the script, and we just keep iterating this way. So to help with making this a manageable PR, the script will make a commit after it does each search and replace. So like every commit in this PR will just be a long list of the exact same change over and over again. So that actually makes it a lot more readable. You can just look at the commits one and after another and just confirm that they do a simple change over and over again. So we did some groundwork for this, like changing some of the things that seemed too complicated to basically script. We did like a few small changes in a separate branch, which can easily be kept up to date because it doesn't have huge changes. And then the script, when we run it, will create a new branch on top of this like groundwork branch, and it throws all of that work away the next time you run the script. So every time we recreate it from scratch. And if we need some small manual changes after the migration, we instead put them into the groundwork branch, so they're applied before, which means that like that branch will probably not build, but once you've run the script, it should build. And the idea is eventually, once we've repeated this process enough times, we can run the script and we have a building working code base that is fully migrated in one go. And it actually worked. We did manage to build this. Here's what part of the script looked like if you want to bleed from your eyes. This is a lot of little invocations of Perl to do different kinds of search and replace and fixing things up, and there was a lot more of this. But that means that, we could finally make the PR. We could put the script into the PR. So, instead of reading through the PR, you can try reading through the script and seeing if you agree with the changes it makes. And we did this. We reviewed it. We merged it. So now we can actually think about migrating to Swift 6. None of this has touch Swift 6 at all yet. This is just groundwork we had to do to be in a place where we could even think about doing this. So basically, once we did the automated migration, we started doing like cleanup because we'd added like these helper functions and things to match the APIs directly, but like we don't need them anymore. Now we can do like small changes bit by bit to the things that we are not fully happy with from the automated thing. And then we can start migrating. So we have a code base now that is very modularized. And yeah, the logical approach here seemed to be that, okay, well, we just take a couple of modules, we migrate those to Swift 6, and then we can do this bit by bit, like we couldn't do with the last thing. So like this should be easier. We can just do little bits here and there and just keep going until we have it all migrated. So as a quick test, we migrated some of the core services, some low-level code, and like we used all of the tooling we'd built before, and we migrated these to Swift 6. And it turns out this was actually easy. Like it wasn't a big deal. Like we'd already built the tooling that solved all our difficult problems. So now we just had to do a bit of editing here and there, had to fix some warnings and errors. Like that was easy. Or was it? So now we come to an interesting little point where we realized we didn't quite understand what you were doing yet. So we started getting reports of high crash rates after we merged all of these changes. I think we were actually at a big Vault event at the time, and we ended up standing at a table somewhere were we at the ice hall or wherever, trying to figure this out. And we were getting it was main thread issues and it was crashing, and that's what we're trying to avoid. Like, what's going on? Like, the whole point of migrating to Swift 6 was we won't get crashes because of main thread issues, right? So why are we getting them? So it turns out there's like this subtle but dangerous issue with combining Swift 5 and Swift 6 that we hadn't realized. So to summarize the problem here, like first we look at Swift 6, how that works. So it has some concurrency safety already. Like it does a little bit of work towards making concurrency safe, but it very much leans towards not breaking existing code. So that means it does make a lot of assumptions to keep like the existing code working smoothly and assuming that the programmer knows what he's doing and it's fine. So it actually turns out that it's quite easy to accidentally call a function that's marked as main actor, that should only run on the main actor. And it's quite easy to call it while not on the main actor by accident, because the compiler goes, oh, he probably knows what he's doing. That's fine. Let's do it. Now, Swift 6, on the other hand, it implements strict concurrency safety. Like, it is strict about this. It is not at all as easy to trick it into doing stupid things. And it will require you to fix your code to make sure that it's correct. And internally, it relies very strongly on this guarantee. It knows that it's enforced this, and it wants to rely on it like very strongly. So basically, to ensure that this safety is correct, then it will actually check when you call a main actor function. It will check that you are on the main actor, and if you're not, it will just crash, because it will assume that something has gone very wrong. It's better we crash now, because otherwise all of my assumptions will not be true anymore. So the thing is now, if you have Swift 5 and Swift 6 in your code base, so Swift 5 will happily call into the Swift 6 code with its very sloppy checking, but Swift 6 will still apply the main actor tests and crash. So if you mix both of them, that is a lot more dangerous than using either one on its own. And basically what we had to do, we had to roll back our Swift 6 changes and start using Swift 5 again, which was very annoying after all of that work. But basically, we did have a plan then for what to do. So what we did was we found all the compiler flags you can give to the Swift compiler to turn on Swift 6 features in Swift 5, because most of them have a flag you can turn on in Swift 5 mode. And interestingly, even if you turn all of them on, it doesn't turn on the like hard checking for main actor functions. So that one piece is still missing, but all the other stuff is enabled. So basically, yeah, we get all the warnings, we get all the errors that we would have to fix in Swift 6, but we're still in Swift 5. So we can actually fix all of the code now without introducing the new crashes. So it looked something like this. Like for all of our Swift packages, we added this like long list here of all the different options turning on them. But as you can see at the top, this is still marked as it's Swift 5 mode. So basically, we did all of that. We enabled that for the code that we had migrated to Swift 6 already. We rolled the compiler back to 5, and then we turned on all the things. So well, we're still not done then. So we have the code running now with some parts in this fake Swift 6 mode, which is actually Swift 5, but it's very similar. So but like all the other code isn't done. So what we did then, we have to start migrating again, package by package, everything, but we migrated to the fake Swift 6 this time. And we already migrated services and shared code and stuff. Then we get into the politics. We got all the feature teams to add the Swift 6 migration to their roadmaps and to be done by summer. This was happening. We're now around New Year's-ish time. So we got the teams to promise that they will get all their code migrated by summer. And in practice, people from other teams, if they didn't have anything to do, they could go and help out some other team with doing the migration. The migration was basically go to your Swift package, add all of these flags, start fixing warnings and errors. And basically this was proceeding quite nicely. And the idea was that then once we got all of them migrated, then we could throw the switch. Then we could switch to actual Swift 6. So we did them all at the same time. So there is no risk of mixing the two. We migrate everything to fake Swift 6, and then in one big go we switch everything. So did this work is the question. And the answer is no. because that's okay. Well, it almost worked. We were almost there now. We found there are more loopholes. Like a lot of Apple APIs are a bit sloppy still. They are using these like pre-concurrency flags to allow them to be sloppier. They have closures that are not marked as sendable, and then they call them on a background thread anyway, which they shouldn't do. Combine was a big problem here, like map and filter and functions like this are not marked as sendable, even though they should be. And the thing is, if you call map in a function that is labeled main actor, then the compiler will infer that any closure that is not marked sendable will also be called on the main actor, and it will add the tests, and then Combine will call it not on the main actor, and you will crash. So basically, we had to fix that. We rolled back the change again. Then we fixed like the call size that we'd found. We'd added some wrapper functions that made the like map and filter sendable instead properly. And we hit the big switch again. And this time it actually worked. And that's the end for real. We managed to finally migrate the whole code base. Now, there's a few notes here which you might be interested in rather than just hearing the fun story of how much we suffered here. So, like some practical tips if you're gonna try this yourself. So, like if you have a code base that isn't migrated and you want to migrate it, then the big thing is to be ready for strict concurrency. Like that, all the other changes are not important. Like this is the big thing. Everything else is just little warnings and things here and there. Now, the other thing is that main actor is your friend. Like the main actor, I'm losing words here. Anyway, marking functions and classes as main actor, that's good. So don't be scared to put this everywhere in your code. Like probably you have an app that is mainly UI. All of the code is gonna be running on the main actor anyway. Just add main actor everywhere. It makes your life easier. It makes a lot of your problems go away by just sprinkling that in everywhere liberally. It's fine. Do it. And like these days, like I wrote this presentation a little while ago and then I didn't manage to show it, but since I wrote it, Swift has also added an option to be main actor by default. That's if you can use it, you might as well turn it on. Like it's good. It's good to make things main actor. And then like when you need to run on some other thread, then be explicit about it. That's a good approach. And yeah, like the big thing you want to do is when you have closures, you will want to mark them as either main actor or sendable, like one of the two. Generally don't leave them as neither, because that will tend to cause problems. And if you have like non-mutable types in your app, like your network data, stuff like this, that isn't mutable, just mark it as sendable, because that is free. You don't have to do any change, you just add sendable, the compiler will be happy. And if this doesn't work if your data is mutable, so if you can change it to be non-mutable, do that and then mark it sendable. That will make your life much easier. And you can use actors to help with the concurrency, but that will force all your calls to the actor stuff to be async, which can cause problems if you're using UI stuff, as mentioned. It's not always great, but if you can use them, use them. And when you can't use them, you can use locks instead. For instance, the OS allocated unfair lock is a very good little helper class that will protect mutable data for you. So these are some very good tips to follow. And if those aren't enough and you need to cheat, there's a couple of nice cheats that you can use. This one is an obvious one. This one is fairly good. It's not too dangerous. Basically, if you call main actor.assume isolated, you give it a block. That block will be run as if it's on the main actor. And if you're not on the main actor, you will crash. So if you know you are on the main actor, but the compiler doesn't, just use main actor.assume isolated. That's fine. You can mark types as unchecked sendable. This means that the compiler will think, okay, this type is sendable, you can use it across threads, you can send it everywhere, it's fine, but it won't actually check that it's fine. So it's up to you to actually make sure. So use like the locks mentioned before, or if you're just really sure that it's not a problem, but it's slightly dangerous. There's non-isolated unsafe. You can mark like variables in your classes as non-isolated unsafe, which means they can be mutable and the compiler won't complain even if you mutate them, and you shouldn't be doing that. So we're getting into dangerous territory at this point. Like, you can use this, but be sure that this is actually true, that you're doing the right thing. And you can use pre-concurrency import on like external libraries to tell the compiler that, okay, yeah, this is an old library, it doesn't understand concurrency at all, just ignore everything here. But now you're really playing with fire, because that library might do anything. So you have to be sure that you know what you're doing. But these are good to know about. All right, that is actually the end. There's a link to the main actor publisher library that we made if you want it. It will probably help you if you're doing this kind of work. So I very much recommend using it. But yes, thank you very much.